Hello everyone, I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BH Varanasi. Let's start the today session. This is on the last session, or a problem solving session, and we want to talk about the Fourier transform of Gaussian function and sampling time period, sampling theorem. How can you sample any periodic signal or any signal? How can you sample this one? And how can you find the Fourier transform of a Gaussian function? Gaussian function is in the form of 1 the root of 2 pi sigma square and e to power of minus t minus u square divided by of 2 sigma square. Means Fourier transform of Fourier transform of Gaussian function. Okay. Gaussian function is denoted as 1 of divided by of 2 pi sigma square into e to power t minus u square divided by of 2 sigma square. This is known as the Gaussian function. Where u means the mean of the Gaussian function. U is the mean of Gaussian function. And sigma square is the variance of Gaussian. These two. What happens if the mean of Gaussian function is 0 and variance is 1? Then this function is looks like a wheel. Means if mean of this function is 0 and variance is 1, it means 0 mean unit variance. Zero mean unit variance. Then this function is, looks like where like that, and this width denoted as the variance. And after putting this one is equal to 0 and sigma square is equal to 1, and the whole function of ft will be looks like 1 divided by of 2 pi root of 2 pi and e to power of minus u is equal to 0, sigma square is equal to 1, then this will be a t square divided by of 2. Same thing if you take, let's say k is equal to 1 by root 2 pi and a is equal to pi, oh sorry, a is equal to 1 by 2, and this whole function looks like general way, in a general way, k into e to power of minus a t square. This is a general way solution of this function, general way reduction of Gaussian function k into e to power of minus a t square. Then after you have to find the Fourier transform of this function. Then how can you find the Fourier transform? Simply uh, see the procedure. How can you find the Fourier transform of this type of function? E to power of minus a t square. If there is a e to power of minus a t, and this is different thing. You can find the easily the Fourier transform of this function. But here is a e to power of minus of a t square. That's why this is a problem to find a direct using a formula for finding the Fourier transform. For finding this type of function, I simply use an example. Xt, I will simply e to power of minus t square. If you compare this one to the k into e to power of minus at square, then we will find k is equal to 1 here and a is equal to pi simply. Then how can you find Fourier transform of this one? Fourier transform of xt. It means Fourier transform of e to power of minus pi t square. This will be x omega. You know about the Fourier transform formula. This will be minus infinity to plus infinity xt. It will be minus of pi t square into e to power of minus j omega t into dt. This is the general way, simple way. Oh, using direct way to find the formula. Why the formula? But there is a problem to integrate the e to power of minus t square. If there is a e to power of t only, then you can integrate the function easily. But there is the e to power of t square, and that type of function, how can you integrate direct? This is the problem. Then simply for finding the Fourier transform, this type of function, I written this one xt as same as xt e to power of minus pi t square. Then what happened to differentiate at both sides? Then this will be differentiation at the right side also e to power of minus pi t square. dy of dt xt differentiation of this one e power t differentiation of e power t is equal to e to power t only. Then this will be e to power of minus t square, same to same. Then after e to power of say this one pi minus of pi t square, if you differentiate this one, this will be 2 pi t is there. Clear? It is only minus of 2 pi t into e to power of minus pi t square. This function is same e to power of minus of pi t square. You can easily write this one as well, like equal to the xt. So looks like xt this way. That's why you can return in place of e to minus t square pi minus of pi t square. You can write this will be xt. Okay. Now you can take the Fourier transform for the of the both side. Both side. Here you know about the xt's. So for the, by the properties, there is a xt have a Fourier transform of x omega. If you differentiate this one, the Fourier transform of this function, is equal to j omega into x omega. If there is a differentiation in time domain, then frequency domain you can simply multiply up j omega. This is the property of differentiation in time domain. Another property is, what happen if the same xt have some Fourier transform of x omega, then if you multiply up txt, then Fourier transform of this function will be j d x omega divided by of d omega. This is the differentiation property in time domain. This is differentiation property in frequency domain. Differentiation in frequency domain. Okay. You can use these two property. Here is a txt. Here dx by dxt. Okay. Apply Fourier transform both side. It means Fourier transform of d by dt xt and will be equal to minus 2 pi. This is the constant you can take on outside. T into xt. Okay. By the property, this will be j omega into x omega. This is minus of 2 pi. This will be j d of x omega divided by of d omega. J will be cancelled out because of this is both side. J is the both side present. That's why you can be cancelled out. This will be cancelled out. After that, omega minus taken common. So omega by 2 pi x omega is equal to, this one will be d x omega divided by of d omega. This will be 1 by 2 pi. This will be a minus of omega into d omega is equal to here. This will be this, okay. Take a 2 pi here also, here only. This will be d x omega. You can transferring d omega at another side and x omega is the same side. That's why this will be x omega. Now you can integrate both sides. You taken the integration of both sides, then this will be minus of omega 2 pi d omega is equal to d of x omega divided by f of x omega integration both side. This omega with respect to the d omega, omega integration is will be minus of omega square divided by f 2. 2 and 2 pi are already here, that this will be a 4 pi. And this one simply dx omega divided by x omega, it means integration of x 1 by x omega. This will be a log of x omega. Why? Because of integration of 1 by x dx is equal to log x. That's why you can write this one. Now you can take it as anti-log both side. Then this will be e to power of minus omega square divided by 4 pi minus of omega square is equal to x omega. Taking the anti-log at both side. It means x omega is equal to e to power of minus of omega square divided by 4 pi. This is the Fourier transform of xt. Okay, in a radian per second. This will be a radian per second. Same thing if you want to transfer in hertz, then simply use 2 pi f at place of the omega. This will be a minus omega. This will 2 pi f. It means a 4 into pi square into f square divided by a 4 pi. 4 pi will be cancelled out. Pi f square is remaining there. Then x f is equal to e to power of minus pi f square. This will be in hertz. It means you can say the Fourier transform of k into e to power of minus a t square. Fourier transform of this function will be a k root of pi by a e to power of minus omega square upon 4 pi of 4a. This will be x of omega. What happened if omega is equal to 0? At a 0, the value at origin at a 0 frequency, this will be minus infinity to infinity. Simply Fourier transform we know about minus b to infinity xt into e to power j omega t. Then j omega is equal to 0. Then e power of something is e to power of 0 is equal to 1. Then only xt is remaining. This will be same thing. Integrate, you can integrate this one. Xt is this one, k into e to power of minus a t square dt. And you know about this will be Fourier transform of k into root of pi a into e to power of minus of omega square divided by 4a. If omega is equal to 0, then the whole function will be 1, and whole value of that function will be pi by a only. K into root of pi by a. This is the value at 0 frequency. Okay. Sorry. Simply, I want taken a example basis on this one. If function of ft is equal to 1 by root of 2 pi into e to power of minus t square by 2, then the area of ft. How can you calculate the area of ft, where ft is equal to 1 by of root 2 pi into e to power of minus t square by 2. You know about the area, simply in simple integration. A single integration of any function is divided at the area of that function. From this will be minus infinity to infinity xt dt. This will be the area of the function ft, or any function. And for this theorem, from this theorem, you can say the area of any function, it will be same as the value of that function in frequency domain at zero frequency. This will be equal to 0, or x omega at omega is equal to 0. And this one is the same as the k into root of pi by a. You have to decide what is the phi, what is the a, what is the k for this question. Here is k is equal to 1 by of root 2 pi and a is equal to 1 by 2. Then the area is equal to k into root of pi by a. K is equal to root of 1 by root of 2 pi into root of pi divided by of 1 by 2. This will be root 2, root of 2 pi will be cancelled out. This will be 1. Okay, you can find the answer for this question by using this theorem. Now I want to talk about the sampling theorem. How can you sample any function? For this sampling theorem, first of all, in the Fourier transform of periodic signal. After that, you start the sampling theorem. Fourier transform of periodic signal. You know about the Fourier series. Fourier series is the analysis of the Fourier any periodic signal about its order of harmonics. You know about the expression of that function in complex exponential Fourier series. It will be a summation of n is equal to minus infinity to plus infinity Cn to e to power of j n omega naught t, where omega naught is equal to your time period. Sorry, fundamental frequency. This will be a 2 pi by t, where t is the time period of that function. Okay, a periodic signal is written like this one in the Fourier series, in complex exponential Fourier series, where Cn is the complex exponential Fourier series coefficient. Okay. Now, if you want to find a Fourier transform of that series or that periodic signal, then how can you find the Fourier transform of that function? Simply Fourier transform of xt. This will be Fourier transform of same thing, right side also, summation of n is equal to minus infinity to plus of infinity Cn e to power of j n omega naught t. Summation, and this is that mathematical operation who can interchange. Then Fourier transform of e to power of j n omega naught t. Suppose if you multiply by 1, then what happen? If xt is equal to 1 and you multiply of something like e power j n omega naught t, then what is the Fourier transform of that function? Okay, wait, I will explain. What is the Fourier transform of xt? Suppose there is a xt, I have Fourier transform x omega. Okay, if there is any multiplication of e to power of j n omega naught t in time domain, then what is the Fourier transform of that function? This will be simply x omega minus of n omega naught. Okay. Same thing you can do here. If the Fourier transform of 1, what is the Fourier transform of 1? Is equal to 2 pi del omega. Then what is the Fourier transform of e to power of j n omega naught t into 1? It's going to simply, this will be the time shifting property in frequency, time shifting property of frequency domain. This will be a del of omega minus of n omega naught. Okay. Then what the next? Know about x omega. We'll find the x omega of this one. Summation of n is equal to minus half infinity to plus half infinity Cm into Fourier transform of that function. It will be a 2 pi of del omega minus of n omega naught. Then you know about the Cn. Know very well about the what is the Cn. Cn is equal to 1 by t integration of minus t by 2 to plus of t by 2 xt into e to power of minus j of n omega naught t. This is the Cn. This Cn you can calculate by this one. Now x omega is equal to summation of n is equal to minus infinity to plus infinity Cn 2 pi del of 2 pi. You can exchange omega into 2 pi f, then this will be 2 pi a common. This function is f minus of f naught. And you know about the del of alpha t, this will be 1 by of mod of alpha into del t only. And this 2 pi the denominator of that one. That's why x omega, this will be summation of n is equal to minus of infinity to plus of infinity Cn into del f minus f naught. So n f naught because of n omega naught t is there. Okay. This is the Fourier transform in frequency domain. This is in the R. Let's have taken an example about this one. Fourier transform of a impulse train. And you know about impulse train, it will be xt is equal to summation of n is equal to minus infinity to plus of infinity del t minus of nt. Where capital T is equal to time period, n is equal to integer from minus infinity to plus of infinity. Okay, everyone. Let's solve this question. Impulse train, it means simply if you put the n is minus infinity to plus infinity, then how can you find how it looks like? Okay. There will be a value of minus infinity. If put away this is the 0, whatever with 0 to infinity first, you put the 1, then this will be t, If n is equal to 2, this will be 2t, then 3t, then 4t, then this will be a 5t, 6t, dot dot to infinity. Same thing in negative way, this will be minus of t, minus of 2t, minus of 3t, minus of 4t, minus of 5t, minus of 6t, like that to infinity. Value of impulse, you know about the this one will be 1 unit impulse, 1 1 1 1 goes to infinity. Impulse 10 less, this one looks like that. This is the impulse time, unit impulse time, which can be written as summation of n is equal to minus infinity to plus of infinity del of t minus of nt, where t, capital T, is the time period. Okay, this signal is repeated after t time period. That's why this function looks like that. Then, what is the Cn for this function? Simply summation of n is equal to Cn 1 by t, difference integration of minus t by 2 to t by 2 xt into e to power of j n omega naught t, value of x 0, where xt is equal to del t. If you integrate this one, the value at 0 is the Cn. Cn is equal to x0, which one is 1 by t. X0 is equal to 1, then 1 by t is the common function factor, that's why it will be a t. Like that, this will be 1 by t, integration of minus of t by 2 to t by 2 xt e to power of minus of j n omega naught t in dt. Xt minus t by 2, this will be dt, t by 2 here, t by 2 here, minus of t by 2, this will be plus of t by 2, only delta t is available, del t. It means at 0 value, at 0 value is 1, then Cn is equal to 1 by t x 0, this will be a 1 by t, 1 by t is the Cn. Okay, the next omega, Fourier transform of this one, this will be a 2 pi summation of n is equal to minus of infinity to plus of infinity 1 by t to del of omega minus of n omega naught 2 pi summation of n is equal to minus infinity to plus infinity Cn and the value of xt. Xt is equal to this one. This will be a summation, Fourier transform of that function. This will be 2 pi by t, and the summation of n is equal to minus infinity to plus of infinity del omega minus of n omega naught. 2 pi by t. It means the difference between the both function xt and this one is 2 pi by t only. Here in omega naught the function is 1, 2 in place of t. Remaining all of things is same. You know about xt. Xt is a summation of n is equal to minus infinity to plus infinity del of t minus of nt. And x omega is this one. So Fourier transform of an impulse train is simply changes in the magnitude 2 pi by t, and this will be in t in place of t is equal to omega. And this function you can draw at xy axis 0. This will be a n omega naught to whole, you can say n omega naught. This will be like that 0 1 2 3 4 5 6 to infinity. This will be minus 1 minus 2 minus 3 minus 4 minus 5 minus 6, like that. Value of that function simply 2 pi by t for all function. 2 pi by t here, 2 pi by t here, 2 pi by t magnitude is same for the all. Here also this function is 2 pi by t, 2 pi by t, 2 pi by t. This is the Fourier transform of impulse train. This is the impulse train in time domain. You can say that impulse train in time domain, and this one impulse train in frequency domain. In frequency domain. Okay. Next, we start the sampling. How can you sample any signal? Instead of this one, a periodic signal, how can you find the Fourier transform? This is the impulse train. Next one, I have taken a common example, the Fourier transform of xt, where xt simply a common, you know about this xt very well. 0, this will be a t by 2, this is the t. 0, this will be a minus t by 2 t. Or the Fourier transform, not the Fourier series. What is the Fourier transform of this signal? This is the periodic signal in time domain. Then what is the Fourier transform of this signal? How can you write this signal in frequency domain? Okay. You know about this type of signal. This signal C naught, same thing 0. It has a naught is equal to 0. This is the odd function. That's why a naught is equal to 0. A bn is equal to 2a. by n pi, where n belongs to odd integer. So how can we write n as Cn? Cn is an minus of j bn divided by of 2. Oh, not 2, this is the 4a for n is integer, odd integer. Then this will be a 2a divided by of j n pi. This is the numerator is a minus of j, that's why you can send to the denominator. The denominator will be j. Cn is this here. Then how can you find the Fourier transform x omega of this type of signal of a Fourier series? You know about this is the 2 pi summation of n is equal to minus half infinity to plus half infinity Cn del omega minus half n omega naught. This is the Fourier transform of a periodic signal. Cn, you know about the Cn here, 2 pi summation of n is equal to minus half infinity to plus half infinity. This will be a 2a divided by of j n pi into del of omega minus half n omega naught, sampling of the signal. This will be a 4 pi a divided by of j n pi into summation of n is equal to minus half infinity to plus half infinity del omega minus half n omega naught. This is the Fourier transform of this function, the periodic function. Okay. Suppose if you extend this one minus 5 to plus 5, then how this signal looks like? This will be minus infinity to plus infinity, but I extend this one from minus 5 to plus 5. If this is the minus 5, then n is equal to minus 5. It means in denominator is minus of j 5 pi. Minus of j, if you put minus j denominator and numerator, if you multiply, then there is that complex function j is go to numerator. That's why this function will be j 4 pi of a divided by of n is equal to 5 pi and del omega minus of 5 omega naught. Sorry, minus 5, you put the minus 5, this will be plus of omega naught. Only odd function is there, then 5. After that, this will be 3 only. J 4 pi a divided by of 3 pi del omega plus of 3 omega naught. What about the 0? After that, this is a 1 minus of 1. Then j 4 pi a divided by of pi into del omega minus of plus of omega naught, n is equal to minus of 1. What about the 0? After the 0, c naught is equal to 0. That's why there is no 0 function. It means after that this will be the negative plus of 1. Plus of 1, it means j function is denominator. 4 pi a divided by of j pi into del omega minus of omega naught plus j 4 pi by 4 pi a divided by of j 3 pi del omega minus of 3 omega naught plus 4 pi a divided by of j, this is the 5 a pi del of omega minus of 5 omega naught. This thing is written as this will be written as 0 minus of 1 also 1 2 3 4 5 like that. This will be minus of 1 minus of 2 minus of 3 minus of 4 minus of 5. Now what is the 0? At 0 value is 0, at 1 value magnitude of this one same thing, j will be cancel out in my magnitude function, that's why this will be a 4 pi a divided by a pi at 1. 4 pi a divided by a pi, it is 4a only. 2 is 0 at 3, so will be 4 pi a divided by a 3 pi. 4 is 0 even function. 5 4 pi a divided by a 5 pi. In the negative side same thing, magnitude will be same, this will be 4 pi a divided by a pi. Then at minus 2 value is 0, after the minus of 3 magnitude of this one will be 4 pi of a divided by of 3 pi. Fourth one is 0 even function. Next one is 4 pi of a divided by a 5 pi. This will be goes to infinity, because of this function will be minus infinity to plus of infinity. Means you can say the Fourier transform of this type of periodic signal, this will be, this is the this type of the periodic in frequency domain. Okay. Let's start the sampling theorem. How can we sample of any signal? Suppose you have some signal, this will be looks like that, this will be xt, this is the xt. If you multiply a impulse train in this a continuous signal, impulse train is looks like that, simple. unit impulse train. 0 t, 2t, 3t, 4t, minus of t, minus of 2t. Then your sampled signal simply looks like that. So 0 t, 2t, 3t, 4t, minus of t, minus of 2t, 3t, 4t, or 5t, like that. It means the sample theorem, sample to, this one will be looks like that, same as the original signal, but at sampling. It means this is the xt. If you multiply of impulse train is n is equal to minus of infinity to plus of infinity del t minus of nt. This is the impulse train. Then the output of this one is this thing is summation of n is equal to minus infinity to plus of infinity x of nt into del of n del of t minus of nt. This will be also known as the yt, sampled output. Ys also can say sampled output. This is the impulse train. By multiplying impulse trains, then you can find the sampled signal of any signal. You can sample by multiply the impulse train. Then how can you find the Fourier transform of this type of signal? A sampled theorem, sample the signal. How can you find the Fourier transform? Sampled output is written as xt into x1t. I written as this one as the x1t. This is the xt. This was the x1t. Multiplication in time domain, it will goes to, in frequency domain is the convolution. Then Fourier transform of this type of function, it will be Fourier transform of the time domain will be convolution of x omega, convolution is x1 omega, or in this will be in radian per second. The same thing written in want to write in frequency, the 2 pi will be cancelled out. This function will be xf convolution with x1f. This will be in hertz. First of all, trying to this one solve. Ys omega is equal to 1 by f 2 pi x omega. X1 omega, it means this is the sample simply impulse train. Impulse train Fourier transform of impulse train is equal to 2 pi by t into summation of n is equal to minus of infinity to plus of infinity del of omega minus of n omega naught. Where you know about the n omega naught? Here is the sampled frequency. Which one is the 2 pi by t is the time period. This is the 2 pi by t. You can common. And this is 2 pi. 2 pi. 2 pi will be cancelled out. Only 1 by t is remaining here. 1 by t x omega convolution of n is equal to minus r infinity to plus r infinity omega minus of n omega naught. Okay. This is the mathematical operator. You can interchange total as summation as minus infinity to plus half infinity x omega into del of omega minus half n omega naught. Sorry, not multiplication. So the convolution. The convolution property you can interchange. By the convolution property, you know xt into del convolution with del t minus t something. This will be a same as del t. It means ys omega 1 by t is written as summation of n is equal to minus infinity to plus half infinity. This will be x omega minus half n omega naught. This is the del function. A convolution with any del function. This will be replaced. This will be replaced by this one. This whole function replaced by the in x domain. This is the convolution of any impulse function. This will be in a radian per second. And frequency domain, same thing. Sampled output at frequency 1 by t is equal to frequency, sample frequency, summation of n is equal to minus r infinity to plus half infinity x f minus of n f naught in hertz. This is the transfer function of a sampled signal. How can you sample any signal? By using a impulse train. Simply impulse train multiply with the say that signal, then that signal will be sampled by the impulse train. And if you want to find the Fourier transform of that sampled function, this one, you can use convolution theorem. And using the convolution theorem of impulse train, impulse function, and this will simply replaced by the this function omega minus and omega naught t. Sorry. Okay. Suppose I of signal in frequency domain signal is simply this type, which one will be minus half and omega m to plus half omega m in a radian per second. In frequency, this will be FM. FM is the modulated signal. Written as FM as the signal frequency, periodic signal frequency, and Fs is the sampling frequency. In sampling frequencies is like a del nt. You know, this is the summation of n is equal to minus infinity to plus of infinity del t minus of nt. This is the sampling minus me to plus infinity. But then what happened if sampling theorem, sampling frequency is greater than up to modulated signal? Or you can say the fs minus of fm is greater than fm. No need of this one. I will explain later. Therefore, sampling frequency is more than the twice of the modulating signal. This is your original signal. This frequency is fm minus of fm to plus of fm. Okay. Next impulse train occurs at fs, then 2fs. Same thing here also, minus of fs sampling frequency minus of 2fs. Then same thing, a sample is at 0, another sample at is fs, another sample is this sample. This is the impulse train. Okay. Then this signal is shifted, same thing at fs also. Like that. What is the coronal frequency of this one? Coronal frequency of this one is, this is the fs plus of fm, this is the fs minus of fm. Okay. Another is this coronal frequency is 2fs minus of fm. This is 2fs plus of fm. These two coronal frequencies looks like that because of the, this is the minus of fm and plus of fm. Plus of fm added in your sampling frequency, minus of fm is subtract from our sampling frequency. Here is given in this question, sorry, fs is should be greater than or greater than of 2 fm. Okay, let's draw at the negative side also. Here this will be minus of fs plus of fm minus of fs minus of fm. Then next one, minus of 2fs minus of fm. I write this one here, minus of 2fs plus of fm. Okay. Then what if is given as fs is greater than the 2fm? It means fs minus of fm is greater than fm. You can see here fs minus of fm is greater than fm. That's why there is some gap between them. In sampling, the original sample occurs after that of some time period. Here is some gap between them because of the fm. Minus of fm is greater than the fm. Okay. What happen if there is no any gap? Case second. Okay, second, it means Fs is equal to 2Fm, or you can write as a Fs minus of Fm is equal to Fm. It means both are the same. In this that case, same thing. This one minus of Fm plus of Fm. It is at Fs 2Fs minus of Fs minus of 2Fs. In this case, the Fm Fs minus of Fm is equal to Fm. It means it will be started from this one also. This one only. This is the Fs plus of Fm, but this corner is Fs minus of Fm is equal to Fm. It means both are at the same point. That's why there is no any gap between them. Another signal started from here goes to here. Same thing occurs at this side also. Started from here and go to here. There is no gap between them in sampling frequency. If the sampling frequency is twice of the original frequency, original signal, in that case there is no equal to them, there is no gap between them. All the signal will be coming at the output. But what happens if the sampling frequency is less than the twice of the original signal? Case number third, Fs is less than up to Fm, or you can say Fs minus of Fm is less than of Fm. What happened in this case? Simple signal. I write it this one. Minus of Fm plus of Fm. This is 0. Next Fs. Next is 2Fs. Fs 2Fs is not, or Fs 2Fs. What happened here? Fs minus of Fm is less than Fm. It means for this signal, Fs minus of Fm is less than Fm. It is from here something. We started from here and goes to here. Next signal started from here and goes to here. Same thing is negative side. Started from here, goes to here. This one also. It means there are some aliasing effect is there. Yes, there is some crosses. Some of the signal is eliminated or ignored in this case. This is not a original signal. We will not get the original signal at output side because of some of the signal will be eliminated here, cancel out. It means this signal is looks like this one, like that. This gap is known as the aliasing effect in sampling. It means if you reduce the sampling frequency less than the modulated frequency or original signal, then there is a effect, a aliasing effect, which one is reduce the original signal or disturb the original signal. The output will be not the same as the original signal. It means to avoid the aliasing effect, sample rate should be fs should be greater than or equal to 2 fm. Then their original signal is not distorted. We will get the full original signal. We greater than this one, we will get this type of signal or this type of signal. This is not a distorted signal, but this is the distorted signal. That's why the sampling frequency should be greater than a twice of original frequency signal frequency. Okay, this is the known as sampling. Let's start a signal question. I have taken an example of filter. How can you filtering the any signal? Of a sampled signal. Consider x. Consider xt is equal to 5 of cos 400 pi t is sampled at the rate of 300 hertz. Frequency is 300 hertz, and its pass is passing through a filter. There is two filter. There are two question. Question number A filter f1, first filter f1 is equal to sine of 2 pi into 150t divided by of pi t. Second B second filter is equal to sine of 2 pi into 210 210 t divided by a pi t. Then the output of this one like y1t and y2t each. The same signal passing a filter second first, then what is the output? Then if the same signal passing through this filter, then what is the output? It means the question says that this is the 400t and this will be a sampled at frequency of 300 hertz. Then it will be passing through two filter. Have a two output y1t and y2t. Filter A is sine 2 pi into 150t divided by pi t. B second sine of 2 pi into 210t 210 divided by pi t. You have to find the output of this function. It means there is a signal is given 5 cos 400 pi t, and this will be sampled at the rate of 300 hertz. First of all, find the frequency of the original signal xt. Fm, you know about this will be omega 2 pi by t. This will be Fm is equal to 4 pi omega divided by 2 pi is equal to 200 hertz by using 2 pi f. Original signal have a 200 hertz. Then first question, first filter if you apply. First of all, find this one will be 5 of cos 400 pi t. Okay, this will be written as 5 cos signal will be written as e power of j 400 pi t plus e to power of minus of j 400 pi t divided by up 2, or you can written as this one will be 2.5 e to power of j 2 pi into 200 t plus 2.5 e to power of minus of j 2 pi f is equal to 200 t. This signal is represented in the plot. This will be from minus 200 to 200. This is the plus 200. This will be the minus 200. This will be minus 200 hertz. This will be plus of 200 hertz. Magnitude of this one will be 2.5. This magnitude is also 2.5. This same thing is sampled at 300 hertz. Then this will be passing through a filter. First one, sinc t, sinc pi t. This will be a sinc sine 2 pi into 150 t divided by pi t. I have a function from minus 150 to 150, magnitude is 1. This will be in hertz. First filter is looks like this one. Second filter, so sinc t formula. Second is minus of 200, oh sorry, 210, minus of 210 to plus of 210 hertz. This is the two, these two function, these two filter have, and this is the original signal passing through this signal. Okay, let's go to solve this. Frequency of Fourier transform and the frequency domain. If you know about fs, summation of n is equal to minus of infinity to plus of infinity x f minus of n fs, and you know about fs sample frequency have 300 hertz. Summation of n is equal to minus of infinity to plus of infinity x f minus of n fs is equal to 300. Okay, let's this is open from minus 1 to 1. Expand this one. If you put the minus of 1 here, then what happened? This will be 300 x f minus 300, so minus of 1, then this will be plus 300. If you put the value 0, then what happened? This will be 300 x f only. This will be n is equal to 0. This one will be 0. Next one, 300 x f minus of 300. to put the value of 1 minus, this will be n. I expand this one from -1 to +1 only. Why? Because of this is the only, that this only signal passing through the that filter. That's why I wrote in this one only. Okay, what is your original signal? Our original signal is this one, this frequency, minus of 200 to plus of 200. Okay, Fs, your Fs is here. Fs, you can say sample frequency have 300 Hz. Sampling frequency is 300. Original signal minus 200, 200. Okay, what is magnitude? Magnitude is 300 into 2.5. 2.5 this one multiply by 300. Here is the frequency xf, f plus 300. Xf is equal to this one 2.5 magnitude. 2.5 into 300, this will be 750. This will be also 750. Fs minus of fm, it means minus fm is 100 hertz. 100 hertz is here somewhere. Here also minus of 100 is 750. 750 magnitude is same, because Fs, first one is the Fs, this will be the Fs minus of Fm. Okay, after that the Fs plus of Fm, if you add, then what the next frequency is 500. Magnitude is same, 500. Here also minus of 500, in this case minus of 500, value is the same, because same thing, Fs is equal to minus of 300 plus of Fm minus of Fm. Plus of Fm is equal to 100 minus of 100, or minus of Fm is equal to minus of 300. This is the Fm. You have to add, this will be Fs plus minus of Fm. In this case, if you plus of Fm, this will be 100, minus of Fm will be 500. This thing is passing, after sampling, this thing is passing through a filter. Which one frequency is first one is minus 50 to 150. Minus 50 to 150, only this value is coming under the first, because of only this is the 150 hertz approximately. So this is the filter 1 output. Only this is coming in after the output, after the filter 1. Okay. Second thing, in second filter is apply frequency, cutoff frequency is minus 210 to plus 210. Then 210 is here somewhere. This is the filter 2 output. This is the filter 1. Okay, it is here Fs plus minus of Fm. If you plus Fm, this is 100, minus Fm 500. for filter 1, yr1t, first response 750, this will be 750 into del f minus half 100 plus this one 750 del f plus 100. You can common 750, then this will be 1 f minus something equal to e to power of j 2 pi in t, this is the in f, this is in t, e power of jt have transform Fourier transform is del f minus of something of omega naught t, like that, plus e to power of minus j 2 pi into of 100t. You can multiply and divide by 2 into multiply by 2, then y var r1 750 into 2 is equal to 1500. This will be e power j theta plus e power minus j theta divided by 2, it will be cos of 2 theta 200 pi t. This is 200t. Filter 1 output. For the filter second, in the filter second, filter first output is, and then this 2 also is there. First one plus second one 750 del f, this will available at frequency of 200, 750 del f plus of 200. If you convert this one in the time domain, then this will be a y var 1, or this will be a 1500 cos of 200 pi t, plus this will be same thing 1500 cos of 400 pi t. We have changed into omega t, that's why this was the frequency 200, 2 pi f is equal to 400 pi. Then common 1500, then this will be a cos 200 pi t plus cos 400 pi t. This is the answer of this filter. Okay everyone, I want to stop this thing here. Thank you to all, and best of luck for our exam. This is the last session from my side. Okay, thanks to all. Thank you and good night.